I want to use this video to discuss the stack. And this is the program I'm going to use to demonstrate how the stack is used. And this assembly code is called func.asm. It's a Windows 32 console program. And here is how you assemble the code. Here is how to use GoLink to link the object file and the libraries. And then here is the directive to declare the entry point. By default, for the GoLink linker, and the entry point should be labeled as start. It's like our main function. Then here we are using two other directives to declare. For this code, we need a printf and exit process from the libraries. Okay, now we are going to declare the data. So this is the starting point of the data section. And within the section, we declare the variables. So one variable is the formatted string here. You can see here, we use db to declare this is a batch string. And this string contains this percentage sign and this d and this now terminator. Okay, so in assembly, we have to explicitly declare the string, including the now terminator. Good, so we are done with our data section. We move on to declare our code section. And within the code section, this is our function. And this function is called a func. And here is the function body. So the first instruction of this function is doing the exclusive OR. And so basically, we actually clear EX and put 0 into EX. Then the second instruction moves 10 into EX. So I feel here really we don't need this first instruction because the second instruction is going to move 10 into EX. And there's no obvious reason we actually XOR EAX. But anyway, this is just an example code. And at the line 32 here, we add a file onto EX, then we return. So now when we return, you can see here, this EX will contain 15. So here is our entry point, our main function. The first instruction of this main function basically calls a func. And the call has a special meaning. We are going to talk about that. The return here actually has a special meaning too. And you have to check what really these two instructions do here. Okay, and we are going to talk about that. And then here at the line 40, then you can see here, we push EX. At the line 41, we push format string. Then we call printf. So these two pushes prepare the argument for printf. So we put the argument onto the stack before we call the printf, and the printf will get its argument from the stack. So it's equivalent to printf format string and then ex. Then at the line 44, we do a weird thing. We add 8 onto ESP. And the reason is when we actually use these two pushes, we allocate 8 bytes onto the stack. And then here at line 44, we have to free the user stack. So that's what we are doing here. Then at line 45, we push 0 onto the stack because we are going to call exit process. It's like exit 0 here. Okay, something like this. Right. Okay. And now let's see, I think we just keep the original function. So now we are going to compile this program. And actually, we are going to first assemble the program. And good. then here, then we link everything. Okay, there are too many things on the screen, so I cleared it. And then here, so I actually you can see the newly created program here. It's here, right? Good. So now let's close this one, and I'm going to use this Immunity Debugger to actually debug this function func.exe. So I load it. So you can see here, the code here are exactly the same as the code of this. So here, basically, it's a deassembly of the func.exe. So this is the main program, and this is the func function. Okay, so they are exact same. Now I'm going to use step-by-step debugging to show you what is going on here. Okay, and then so you can see here, when we run this program, it will stop here at this point. So the ESP points to this location. And what it means is, the stack is being used. We don't care about what happens before. And let's just assume at this point, the ESP points to here. This is the top of stack. And then when we call this function, right, it will do two things. It first actually will push this call pushes the return address of the func. So the return address will be this one, 00401010 here, onto the stack. So basically, so ESP is here, right? 0019FF74 is here. And so what it will do actually is it will push the return address. It will push 00401010 onto the stack. So it will push to here. And this is 74, it will go to 70. Remember, the when we push the data onto the stack, the ESP decreases. So that's just the way how we actually use the stack. Okay, and the lower address actually points to the top of the stack, right? So remember, this will become 70. So then the second thing call will do is it will actually jump to the beginning of the func. So let's just run it. So what I'm going to do here is I'm going to actually do this. I'm going to do step into because I'm going to step into the function. Okay, so I'm step into. Good. So you can see now we move to the next instruction. That's the first instruction of func. So let's see what is happening here. So now you can see now ESP, which points to the top of the stack, and ESP has the address of this. So ESP is 0019FF70, as we predicted before, right? And also at this address on the stack, and at this address, we have the return address, which is 00401010, and that's the address of this instruction, right? Good. Okay, so now we do step over. Let me see here, step over where? Which one? Step over this one, right? So basically, we just run the instruction one by one. Okay, good. So you can see the bottom here. This is a registers window, and you can see now we do the XOR, EX becomes 0. Then we do one more time, EX should become 10. That's A in hexadecimal. And here we do this again, ES becomes basically 15, right? That's F. Then we come to return because we are done with our function. And this return is very special, and it does again, two things. First, it will actually do what? It will pop the value at the top of the stack. So at this point, you can see the top of stack actually contains the address of a return address. But actually, when you come to return, it should always, the ESP should always point to the return address. Okay, and so basically, this return instruction will pop this address here, this 00401010, the top of the stack, into EIP, which is the instruction pointer. Means, okay, when this return is done, it shall actually run the instruction at this location. And then, because we said RETM here pops the return address into the EIP, right? But actually, really, it's just a kind of equivalence. And then, so when we do pop, we actually increase this ESP by 4. So when this instruction RETN is done, and the ESP should increase by 4, it should come back to here. So let's have a look, see what will happen here. So we do step over again. Step over. Okay. So you can see now ESP come back to here, right? And then also we begin to run this instruction following this instruction. So that's the return address. This one actually is at the return address of this function, right? Okay, so now we're good. So we step over again. We push EX and push this format string here. This one actually is the address of the string here. And so what we do here is, let's see what's happening here. We push, and you can see now we push EX, that's 15, onto the stack, right? Then we also push this one. We push this one onto the stack, so that's a format string. And then we're going to call printf. Then printf actually will get its 2 arguments from the stack, and so actually the assembly code of a printf will access these 2 locations and then performing the printf functionality. Okay, and so it will print out the result. Then when it's run, it will print out. So you can see here, it will print out here. It will print out at 15. And then here, you can see now we actually did the 2 pushes, and we actually used 8 bytes of the stack, and we are done with printf, so we need to return the 8 bytes to the system, right? So we need to clear up the stack. So that's what we are doing here. So we add 8 bytes to ESP, and so ESP will come back to this one, so 74. Okay, good. So when it comes back, then we push 0 because we are going to call the exit process. So when we call exit process, this one will clean up everything for this program. So we are done.